It's a great maiden scientific voyage for RSV Nuyina, our world-leading icebreaker, and we're just so thrilled to be able to go and study this glacier and understand the melting patterns and the implications for future sea level rise. It can contribute 1.5 metres to global sea level rise, so it's really important for us to understand what's happening on the glacier. It's an important milestone for Australia's ongoing commitment to Antarctica and Antarctic science.
The East is like the sleeping giant. It holds quite a bit of sea level rise potential, and the Denman especially is 1.5 metre. The importance about that glacier is that it's retreating quite quickly, and it's retreated by about 5 kilometres in recent years. We're trying to take as many platforms to observe as we can. So we're taking some samples through the sensors that we have on board. We're taking some seawater samples as well that we filter and then bring back. We're using even seals. We can put sensors on their heads now, and they can go to places where some of our boats and floats cannot go. So they really help us to get year-round data. We're also taking sediment cores to look at the past. So with those, it's like taking muds on the seafloor. And if you can do that like you do with tree rings, you can go back in time. So we're going to use all these type of different tools and observations to be able to help us understand what's happening in the south.
A major focus of SAFE is to understand more about the benthic biodiversity of the Denman Marine Glacier areas, things like octopus, sea spiders, isopods and the like, and we're very interested in using those to understand more about their diversity, their connectivity to other areas, which informs conservation, but to also use them as a time capsule to look back in the past.
AAPP is going to look at the ocean, how the ocean and the ice interact together and what are the main drivers of the change we're observing now. We know there is warm water in the continental shelf around Antarctica, but what really matters is how much of that warm water reaches the ice.
So every drop of seawater really contains the DNA of surrounding animals and other creatures. So if we take a small seawater sample, we can filter that and then access that DNA to tell us what's living there. So it's a way to do a biodiversity survey. Well, without ever having actually seen any of these animals, we can infer what's living there.
We know the ecosystems is changing a lot, the ice, the sea ice is changing, but you have to be on the ground to get some of that data like sediments and seawater samples. You can't do that just remotely.